Number 22 says the slope of the line tangent to the curve at this point, so I'm given an xy, is what? So I'm trying to find y prime, or f prime of x, however you want to look at it. You're just trying to find the slope. So you should notice implicit differentiation straight off the bat. I'm going to have 2y, y prime. The reason why it's y prime is because we are in respect to x. It didn't mention it anywhere, but the default is when we're taking derivatives, we're always in respect to x. So it's 2y, y prime, and it's going to be chain rule here, plus 3 times the stuff to the subtract 1 power, so it's going to be to the second power, multiplied by the derivative of the inside, so chain rule. So what is the derivative of x times y? That's a product rule in itself. It's the first times the derivative of the second, plus the second times the derivative of the first, which is just 1. Okay? And of course the right side, the derivative of 0 is still 0. So now what do I do with what I have? Well, instead of trying to get y prime by itself, since I have an x and a y, I can put the x everywhere where I see an x. I shouldn't waste time by trying to find y prime all by itself if I have this point. Negative 1 will go everywhere where I have a y, so that I can look at this and say, well, this is going to be a negative 2y prime. This is going to be 2 times a negative 1 is negative 2, plus 1 is a negative 1, square it is a positive 1, times 3, so it's still 3. And then here it's going to be 2 times y plus a negative 1. So we can say 2y prime, that is, and it's going to be plus that y value, so it's going to be minus 1. Still having our parentheses. And we're trying to find y prime. Distributing this really quickly will give us plus 6y prime minus 3 is equal to 0. Negative 2y prime still. So this will give me a 4y prime is equal to 3, because I combine like terms and move this over. So therefore y prime is equal to 3/4. So D would be the answer for 22.